it is week 13 for cycle 1 science experiments. We have 2 this week. So just a reminder, time management is something that you'll want to be doing. Make sure you have some harmony between the 2 experiments. They don't each take the same amount of time. So just balance the time and give each experiment its due. The goals for the experiment are to make sure your students have memorized the steps of the scientific method, help them think it through, walk it through. We want to really focus on observation and letting the students draw out some questions from them. We want to be modeling the dialectic process for them and asking I wonder and how and why sorts of questions, but not necessarily expecting them to do that. It's our privilege as lead learners to be modeling that for them and drawing it out. Our goal is not to teach or even to answer all of the questions that arise in regards to each experiment. That's okay to leave questions unanswered. But the process of wondering and asking the questions is what we're looking for here, in addition, of course, to observation. Okay. So we have 2 experiments this week. We have tilt and splitter, which are really fun. So tilt, this is our 1 experiment on seasons and tilt of the earth. So make sure you're looking at what terms need to be defined here. And even though you think some of the older students might already know some of these words, it's a good thing to review them because they might be rusty and they might not have the words for each term. They kind of know what it is, but they can't articulate it. And this is our opportunity to give them the words, give them the grammar. So words like hemisphere, tilt, seasons, poles, those are all great terms to be defining for this experiment. So we need a pencil. We have our balls. We'll have 4 of these styrofoam balls. The holes I've already pre-punched in each one. There is a seam on these balls, tutors on my campus. Can you see that? There's a seam on the balls that can serve as our equator, but I'll have some Sharpies in the bin if you want to go ahead and mark the equator on there. That's fine. We'll be sharing the supplies. So if there's already the equator marked on there, you won't have the opportunity to do that again because we're going to use the same 4 balls for all 4 classes. How to run this experiment. I suggest you do it as what I call a show and go, that you would demonstrate the entire experiment first, then give the supplies to the students to allow them to work in pairs on the experiment. That way, you do not have to be managing each pair to make sure they're doing the science experiment correctly. What you'll have done is you'll have demonstrated the experiment all the way through. So now both the students and the parents have observed that, and your parents can be your helpers with your students. And there's not so much class management on your end or experiment management because you've already run through. So we have these awesomely bright LED flashlights that we'll be using. So we're going to insert the pencil through the ball and tilt it at about a 45-degree angle. Hold our flashlight source light source about 6 inches away. We'll of course remind our students that our sun is bright all the way around. That it's not just a single-sided light source. That it's a light source that goes all the way around. And that will be important when we rotate our Earth around our sun. So this is our Earth, this is our sun. When our sun shines on the Earth, where do you think the light will primarily shine? Will it shine primarily on the northern hemisphere or on the southern hemisphere? You probably all guess northern hemisphere. Oh, yes, indeed, northern hemisphere. And they'll be able to guess what season would it be. Would it be summer or would it be winter in the northern hemisphere? They should be able to guess that it would be summer. It's also an interesting time to talk about how it's light for almost all day long up in Alaska during the summertime because they're so far north, and when the Earth revolves around when the Earth rotates on its axis, it's light almost all the time up here, and they should be able to see that. I can see that here. I don't know if you can see it in the video, but that's something really great to add. Now we're going to rotate our Earth around the sun. Oh, let's say it's July, August, September, October, November, December. Now our Earth is rotated around our sun. Of course, our sun is a 360-degree light source. Now, what season is it in the northern hemisphere? What season is it in the southern hemisphere? So that's a kind of way that you can demonstrate this experiment. Talk about the why in the Van Cleves. That really is enough. And then give your students in pairs the supplies so that they can navigate that as well if there's time. If there's not, the demonstration is that will suffice perfectly. The second one is splitter. So this is the first experiment in a series of 8 experiments about rocks that we're going to focus on rocks here. So this one, make sure you're reading in your Van Cleves what this experiment is about and what the why is for this experiment. We're talking about how we can use ice to split rocks. So you will fill up the sample cup here all the way to just overflowing, and talk about what happens when, pretend this is a crevice in a rock and it's rained or ice has melted in the summertime and now water has filled up this ice crevice, and what will happen in the winter when that water freezes again. And we can ask, does anyone know what happens to water when it's frozen? And hopefully they'll say it expands. I'm sure somebody's stuck a water bottle in the freezer and had it bulge at the bottom in its expansion. So this actually has been sitting out for a little bit because I got distracted and it has melted, but you can see that it was a good half an inch still above the surface of the rim of the cup. So something that was completely full like this with the lid on. As it froze, it expanded and it popped the lid off. And that's really what happens to our rocks. When the water in the crevice expands, it expands, and the rocks are not very elastic, so it will crack and it will break. So we can talk about how that happens with sidewalks as well, bottles in the freezer, etc. Maybe we can find some cool pictures to bring in for this week. I think that would be really fun, of some rocks that have been split by ice. I'm sure those are on the internet somewhere. So you see Livermore, we will be in the Family Life Center for this experiment because that's where the refrigerator is, so it makes perfect sense for that. And we'll be sharing supplies, so make sure you put this right back into the freezer after your students have taken a look at it. I would advise you to do the tilt experiment first. That way you have enough time for that, because this one can be a very, very short, quick demonstration. So that would be a good navigation of time there. Although this would lead to some interesting discussions on walking on your way back to class. All right, ladies, have a great week, and I will see you on Friday.